Welcome to the Tech Insider, where we talk to the people who can give you the insights and trends that matter to you in your business. I'm Christine Grail with Leica Geosystems.
I am so happy to have with us today Greg Schneider. He is the Industrial Plant Solutions Manager for the Northern US. Welcome to the program, Greg.
Hey, good morning. Welcome. Oh,
So,
not
Greg,
welcome.
all right.
Take
So,
two.
Greg, I think I have seen a photo of you standing in the snow in some very, very cold weather during the polar vortex. Now, I can't promise it was you because whoever it was all bundled up head to toe. Can you tell me a little bit about that photo? Because I think the person was laser scanning. What was going on there?
Sure. Well, with my background in surveying, when you're selling our equipment, you want to make sure that a customer understands what are the real conditions that equipment can function in. And being located in Minnesota and having covered Canada throughout my career, it's important for a surveyor or a customer to know the conditions that they can work in. So oftentimes when we have some extreme weather here where I live, I take the equipment out and tested in real conditions. So that example you saw, we had a polar vortex where the high was 25 below zero at the time. And I took the equipment out to just run it through its paces and see what it could do. And after the 18-minute mark, I got a or a cold temperature warning. And I thought, 18 minutes, that's pretty reasonable to be able to get out, get information that you need in such extreme conditions. I hit the OK button to that, and I was able to continue on for an hour and 20 minutes, just scanning around my house and testing the equipment, various configurations of Field 360, hitting the button on the scanner. And after an hour and 20 minutes, I kind of more or less got bored with what I was doing and felt that I had kind of, for myself, determined what it was capable of doing, and that's where I stopped.
That's funny. You got bored after an hour and 20 minutes. I would think you got cold, but of course, you're from Minnesota, so you're used to that, right?
Right, you just dress accordingly, and it's easy to, you know, to be ready for those kind of conditions.
Talk to me about your surveying background because you started before you were with Leica Geosystems. You started as a surveyor on a survey crew, entry level. So, how did you find your way into surveying, and what was that initial experience like?
Yeah, so I really grew up in the industry. My dad owned a civil engineering company or became part owner. And as a summer job to make money to go to school, I was hired on to be an entry level person on a survey crew. And I was really, really inexperienced at that time and had to really learn. I remember the first task I had was to write station 100 on a lath, and I wrote 100.00, and then the party chief explained to me the actual way that you're to write that type of station on a lath. And then from there, I really attribute my growth in surveying to the crew leaders that I worked with in my early years. They were under a lot of stress to get a lot of work done and had to perform. And primarily the work was, staking subdivisions, curb and gutter, sewer and water. So as a surveyor, though land surveying is boundary work, a great deal of the work that's taken care of is done in just staking projects. So with the pressure that these crew chiefs were under, I had to learn in order to be a useful person on that crew.
How did you go from that kind of surveying into laser scanning? Because at that time, especially, it was a pretty big leap to go from traditional land surveying using total stations. I don't even know if you were using GPS yet, but then to go into laser scanning.
Well, we had adopted GPS at a power company that I worked at in the mid '90s. So you go back to 1982, we were using a theodolite and a chain. So I learned very entry level type of procedures, and then that was 40 years ago. 40 plus years ago. So in 1982. So fast forward to the mid 1980s, from my experience that I had been trained on with the crew leaders, I moved out to Maryland for a time for a couple of years and worked in the meets and bounds. And as part of that role with a small survey company, we were resident surveyors. That's what you call a survey crew that on a pretty regular basis go to a project site or a facility and execute project work. So we worked at a paper mill in Luke, Maryland as resident surveyors. And there we were measuring all sorts of things, essentially doing industrial plant as-builting, if you will, measuring pipes and columns and steel structures. And that's really where, when I saw the technology in 2003, I immediately was able to make that connection of the value of that technology going back to my experience in that paper mill, because of all of the, in order to get a measurement, you had a theodolite with an EDM or electronic distance meter on top, and then that measured to a prism. So in order to get a measurement within a plant facility, we had to climb all over the place with that prism in order to get a critical measurement. And that was really challenging. And I've told stories over the years as I've presented at conferences and so forth, all of the dangerous situations that I really had no business being in as a surveyor, but with the technology, that's all you had. So once I saw the remote sensing capability of laser scanning, immediately I saw the value of its capability.
So going back to 2003, we're going pretty far back in laser scanning. Scanners were very complex at that time. It took a lot of time. I mean, now compared to a lot of the manual measurement methods, laser scanning was fast, right? But it was slow compared to today's standards. It took a lot of expertise to be able to work the scanner, to know what to do with the data. At what point did you say, you know what, this is definitely the way to go? Because it was a really big hurdle back then to get into laser scanning.
Well, I think it was a big hurdle to get into laser scanning, but it's sort of relative, right? The technology at that time was a fixed field of view, 40 degrees by 40 degrees. Maximum scan speed was 1,000 points per second. But again, it was remote sensing. So it did take a little bit more of an effort to do the scanning work. But again, the results of the information that you captured was absolutely remarkable to me. Yes, it was a lot harder to meet with customers and explain that value to them. But some of the early adopters were able to see that value and use scanning on highway projects, and in the industrial plant space. It was a lot easier to, well, I shouldn't say easier, but there was a more of a value proposition with the early scanners to get into an industrial facility to measure.
Well, and especially when you're talking about the safety aspect, because that's really where laser scanning has always provided that benefit in the industrial plant space. Was
Yes.
there a specific project or use case where the value was just crystal clear to you? I mean, going back again to 2003, you kind of jumped into laser scanning on the sales side, but in order
Right.
to sell it successfully, you had to believe in it. You had to believe that this was going to solve some real problems. At what point did you find that that was actually the case, or you were fully convinced?
Well, I was fully convinced at the interview when I learned about the technology and had an opportunity to come on board with Leica Geosystems or Cyra Technologies at the time with the technology. Again, going back to all of the dangerous situations we were in trying to get measurements that laser scanning allowed you to do remotely, right? Remote sensing, so we could reach up to those hard to access areas to get the measurements. And then what really brought it together for me and for one of my early customers that had great success over the last couple of decades, we went to an oil processing facility, and they were already designing in 3D. They were using a total station to take measurements on pipes and steel and pipe supports, for example. And then they would build a 3D model, and they would design in 3D from their single measurements. I went out with, at the time, an HDS 3000, which was the first full dome scanner in the industry. And we scanned the same project area as a demonstration of the equipment. And I remembered I contacted the customer, and and said, hey, we have the data for that piping area where you designed. If you want to compare your final design back to the point cloud, we can do an interference detection. And the owner of the company, just kind of jokingly just said, well, we feel pretty confident that we have everything and we don't need to do any interference detection. So fast forward to they fabricated the pipe, had the spools on site, and they were getting ready to lift them into place. And one thing that they missed measuring with the total station, there was a simple man bridge that went up and over the pipe in the area of the project. And had they compared it to the scan, they would have caught that before they got ready to do the install. In this case, it was a really simple fix. They just cut the man bridge off, picked it up, moved it down, and reinstalled it away from the project area. But I heard from the owner later on and said, Greg, you had offered, us comparing our design back to the point cloud, the scan data, and if we had, we would have caught that man bridge ahead of time. Really had no big impact on the project, but you can imagine situations like that are much more complex. The higher in a facility that components need to get installed. So that for him really convinced him to invest in the technology, and they acquired it 5 systems later. They continued to upgrade their equipment, and now he's retired and really enjoying his retirement fishing all summer long.
Nice. It's great to have those stories. You always hate to have a customer go through a painful experience to learn the hard way. But at the same time,
Yeah.
it does prove a point, right? To be able to show without a doubt that the laser scanning provides a benefit. You've worked in a number of industrial plants. You've been involved in a number of different types of projects. You've seen plants that are using kind of outsourcing their laser scanning, and you've seen plants that have brought their laser scanning in house. We've already talked about the safety benefit. I wonder if where you see the biggest value of laser scanning, is it in safety? Is it in being able to find those missed measurements and those mistakes, or is there some other place where laser scanning just definitively proves its value?
Well, there's a really long answer to that. There are just so many ways that laser scanning brings value. I think one of the highest value propositions for customers that own this is the efficiency that they can get the measurements that they need. You go into an industrial space, and instead of even doing like when we would map a plant with conventional methods, and the customer is referring to it, the oil refinery that was already building 3D models. When you're doing single measurements, that takes an inordinate amount of time. And it's only going to be as fast as you can physically walk through that facility and access a location safely and capture those measurements and take the necessary notes to identify what those measurements represent. Where with a scanner, you're capturing everything very, very quickly. Typical setup now with our current equipment is 1 minute and 51 seconds. So in that 51 second, in that pass, you're capturing everything in the field of view of that sensor. So when you're measuring conventional, you're taking only the critical measurements that you need for your project, and you have a time constraint. So you're measuring what you feel is important. But then down the line, as you start to design and then you go to construction, if you've missed something, what you've missed may be a critical part of that facility. And another good example of that would be the same customer. They had designed their project, and then when they designed in the point cloud, they would just step themselves through with a slice from one end of the plant to the other to see how their new design fit into that space, using the point cloud as their model to do their design. And as they stepped through, they came across an electrical control panel. And the electrical control panel, typically, it would be a lower cost to move that electrical panel or fuse box, and then just run the pipe straight, because that's cheaper than spooling and fabricating welds and bends to go around it. But when they did some investigation on that control panel, that was a critical control panel that ran a good chunk of that facility. So by having to move that, they would have to do a shutdown, shut the equipment down, go out of production, move the electrical box, and then reinstall it, and then they could start that plant up. And that's loss of revenue. So in this instance, they were able to design that pipe to go around the electrical panel because it was more cost effective to the operation of that facility and the profitability of that facility that this project was being executed in.
That's a significant impact on a project's outcome to be able to reduce shutdown time. And then
Yeah,
again, you talk about the safety benefits and all the other advantages. That technology pretty much sells itself right at that point. But now
yeah,
we're in a situation where plants are starting to look at laser scanning, not just in terms of projects where they're expanding a plant or building a new facility or changing a line, but they're really starting to think about that idea of the digital twin and all of the advantages that that provides. And I'm sure, you work so closely with our customers. They really are more like clients. You're walking alongside them. You're helping them. Are you
right.
getting any big questions about the digital twin right now?
Not so much questions. There are questions about the digital twin, but we're seeing more and more that uh, facilities, especially with COVID, where they were caught, they couldn't go in and use their traditional, 2D plans and the information they had on their computers in the office. They weren't going into the office, so they were caught without the critical information they needed for their facilities to keep it operating and all of the things associated with that. So following COVID, there was already kind of an uptick in the digital twin, but following COVID, there's been a much more rapid advancement to wanting to capture the digital twin of a facility. So it's gotten a lot easier, and there's a lot to be there's a lot to talk about in terms of a digital twin and how current technology can assist with that.
What is the biggest advantage you see of having a full digital twin where you're actually going out and capturing the reality of the plant on a regular basis, keeping that up to date and having that information widely available? I mean, there are huge benefits there, right?
Well, there sure is. You're capturing the point cloud and the scan data and the images captured with that scanner is capturing the actual as is conditions of that plant. The 3D models that have been developed over time of that facility, though they're beautiful to look at. There's nothing, a 3D model is really pretty remarkable to look at. But again, you can't build a 3D model detailed enough to show everything. Things inside of a plant are continuously changing, and is one part of the operating plant in communication with the other to keep that model up to date, or if it's going to their P&IDs, their plan sheets of that plant, how up to date are those? And by scanning and having current information, the most accurate information for a plant is the point cloud. The point cloud is the most accurate as built because that's showing the as is living and breathing facility, if you will, all of the details, the conduits, the pipe hangers, you name it. I mean, it's kind of endless the amount of information that is contained in the point cloud. And also, where current technology is, you can use a tablet in the field or a smartphone, and you can do what we call geotagging. You can capture critical information of a facility, a placard, for example, and have that linked directly into the point cloud and the images from the scanner, which makes the visual plant immediately available for anyone within an operating plant facility.
So valuable. I would think that for an operations and maintenance standpoint, just having immediate access to that information is extremely valuable. The visualization, so you can do virtual walk downs. It just makes communication about anything within the plant so much easier. So a lot of value there. I know that the industrial plant market has been using laser scanning for a while. Again, going back to when you came on board in 2003, so more than 20 years. And it's a pretty accepted technology in the industrial plant market. But are there any misconceptions that you encounter, especially with the technology continuing to evolve?
Yeah, there's several misconceptions. Again, there's a lot to be discussed in detail there. One of the big misconceptions is um, how much of a pipe or structural steel do you need to capture in order for that data to be valuable? Um, you know, do we need? A lot of people think, well, we need the entire circumference of a pipe, for example, in order for us to know where that pipe sits, or for us to be able to model that pipe. And that goes to the various products that are available in the market and the various scanning solutions that have been um, put into service in the industry. And then, structural steel, same kind of thing. Do we need the entire wide flange beam to know that there's a wide flange beam there, a column? And you really don't. Like with our software, for example, you only need about 10 to 15% of that cylinder or pipe in order to identify the size of that and be able to model it. Other misconceptions are the point clouds are so big. Oh, they're so heavy. The amount of information that you have is constraining to our computer systems and to have it be usable. And early on, one of the secret sauces for like Leica solutions, for example, is our point cloud engine. Since I came on board in 2003, we've had a point cloud engine that's robust enough to be able to handle tens of millions, hundreds of millions, and now today billions of points, and have that in your software. Bring in an entire facility, an entire point cloud, your true 3D as built or digital twin, and having that information for anyone within the organization to go in, see that data, and be able to do it just through like a published web page. Or if you're designing in a plant, we're going to go a half a mile through that plant and route pipe through that. Well, we can bring in that entire point cloud into a CAD system, AutoCAD or Revit or CADWorks and BricsCAD, and we can effectively use that point cloud as the model and model through that. In the early days, there were a lot of scanners in the industry that you really couldn't do anything with a point cloud. Once you scanned it, in order to do something with that information, it had to be converted into a model in order to effectively design in that type of environment. And that was cost prohibitive. It's very expensive, and it still is today, to spend the time to model everything in a facility, because there's so much information there, so much detail in an operating plant, that it's really cost prohibitive to build an entire 3D model that's your digital twin. Use the point cloud as your digital twin. It's really the currency of a facility is your point cloud.
Well, we've come a long way, and it sounds like the software is enabling a lot more value to be obtained from those scans that are captured in the plant. And it sounds like
Right.
Leica is leading the way. You've been with Leica for more than 20 years now. What is it that keeps you here? What do you like best about the brand and what it has to offer our customers?
Well, we continue to be the industry leader with our solutions, but what's most rewarding for me, and what's kept me engaged in wanting to do what I do, is when you educate the industry and you meet with a customer that has interest in the technology, and just understanding what they need to do, and what are they, not necessarily what are they struggling with. Sometimes they're struggling with things, but educating them how our technology can enhance what they're doing today and make their services more profitable. And then once they make that decision to make that investment, when you work with them and consult with them and you start to see their success, that really keeps me going. I've made a lot of, their customers, but I've made a lot of good friends over the last couple of decades. And it's really rewarding to see their success, and talk with them on a regular basis about that.
Well, and I have to believe that is a big part of the reason why so many customers rely on Leica Geosystems as well, is because of that relationship piece. Because again, you're not just selling them a technology and walking away. You are really in it for the long term with them. You're coming alongside and you're helping them succeed, and that's your goal.
Yes. Mhm.
Okay. So I'm sure that you have meetings with people in the industrial plant space and they're very interested in technology and they want to upgrade and they want the latest and greatest. What are their biggest hurdles to doing that sometimes? There's still hurdles, even where they see the value. What's holding them back?
I think they look at the initial cost, right? It's not a low cost investment. They have things in place and how they're doing things. They're comfortable with the way they're doing things. And then when they look at that cost, it's a challenge for them, especially when you're working with a really large organization. There's a lot of managers that have to have buy-in into that investment. So the larger the organization, generally, it's been harder to get that adoption internally. But when you break it down into simple form, when you're buying a scanner, you're hiring the best person in the world at what they do, and you're hiring them at essentially a one-time cost, depending on how you purchase it. So you're hiring them at if you make a capital purchase, you pay for it outright. You're hiring that person at a one-time salary, and there's no overhead. There's no sick time. Granted, you could look at maintenance and your CCP, which is customer care for your product. That's your benefits for that employee. But they're just bringing tremendous value to that organization. So once you make that investment, a lot of times it's looked at. We need to make that purchase for the large project. We need to have a large revenue stream that can pay for this investment. And what it boils down to is once they have that equipment, they find all sorts of ways to use it. It can be used on very small projects, and I kind of equate that to, I have a scanner as my demo gear, and I can go out and scan the underside of my deck to do a storage upgrade, and I'm able to capture that information, that 3D information, put it into CAD, and effectively make good decisions about the materials I need to buy to do that. So it's kind of where things are at in a facility. There's a lot more risk involved, so you make the investment, you're really mitigating risk. So that investment just has a lot of unseen value and unmeasurable value. And some of the instances over the years, the safety aspect. How do you put value on an employee's safety, and scanning really helps with that. So that's a few examples of some of the hurdles, but some of the unseen hurdles and objectives that are accomplished once you make the investment.
Well, and again, it sounds like plants are increasingly seeing the benefit of bringing that scanning technology in house, bringing the expertise in house. So, where once, probably back, in the early 2000s, they were outsourcing that capability. All they wanted was the models off the data. They didn't want to get in the data themselves. Now they're starting to see the value of owning that process, and so they're looking for people who can help them do that. What are those top skill sets that people need to bring in with them because of technology now and how everything has changed? What should they be looking for? And for someone who wants to get into the plant market in that role, what skills do they need to bring to the table?
Well, I think they have to be a driven person, right? You want to hire someone that has a lot of drive to, produce, have interest in the industry that they're involved in. And one reason a lot of that equipment was brought in house, again, if it's outsourced, it started to become cost prohibitive in a way, or it was very expensive for them because a project comes up, they have to go through contract. They have to get an estimate on that work, and some of the information that they need very quickly gets pushed out several months before they have the information that they need. So bringing the technology in house allows them to be a lot more responsive as questions come up or smaller projects, or they need that 3D information very quickly. And then what's really one of the challenges will be, I think, people coming in new from college may not have the practical experience as someone that's been in a facility for a long, long time. But if that person is willing to learn about that facility and understand how it operates, there's going to be a lot of benefit there. But one of the advantages of new people coming into the industry is they have 3D experience. The old days, everything was done, 2D planimetric on a drafted or a plan sheet or a 2D PNID. But in today's world, young people are used to doing 3D gaming. They're very used to that 3D environment. So they're able to adapt very quickly to working in a 3D environment from a design standpoint and being able to navigate, negotiate through a point cloud when they're using that data for design purposes.
It's all like a video game, right? I mean, I guess that's the advantage of laser scanning for the digital natives, as they're used to that environment. But you mentioned a willingness to learn. And I think with technology moving as rapidly as it is today, that willingness to learn is really the critical piece.
It is.
So what do you like best about your role in Leica? You work with so many different types of customers and so many different types of applications. What is it that you are just excited about when you get up every morning and start your day?
Well, I think I already alluded to it earlier on, and that's engaging with new customers and existing customers, and just working closely with them to their success. If they're not successful, Leica and myself, I won't be successful. So having that engagement with those customers on a day-to-day basis, gets me up in the morning and excites me.
Well, and the opportunity to stand outside in 25 below zero weather with a laser scanner. I mean, that's exciting, right?
Yeah, that too.
Okay. What are you watching or listening to or reading lately that you think our audience would find interesting?
Uh, you know, nothing real specifically. It's just kind of keeping tabs on what's happening in the industry through LinkedIn, through different, you know, user groups, that type of thing. Just kind of checking in on that. Nothing real specific that I'm reading.
Okay, so you're all business then. What do you do in your downtime? You're in Minnesota. Do you hike? Do you fish? What kind of stuff do you enjoy doing?
I just have a lot of interests. I'm a very active person. Love the outdoors, boating in the summertime, swimming. Love jumping off the dock in the summertime at the cabin. You just can't beat that. It's and doing that with your kids and family. And then the wintertime, I enjoy getting out. Obviously, you see that I have no problem getting out when it's 25 below. In fact, I look forward to that so that I can test our latest equipment that's on the market and how it's going to perform in that. But I like snowmobiling and getting out in the winter. So being in Minnesota, you have to really embrace the seasons, and I enjoy that.
You have to not be afraid of the snow and cold if you live in Minnesota, that's for sure. Well,
Yeah.
Greg, thank you so much for joining us today. It has been a pleasure speaking with you, and I hope to have you on the program again at some point in the near future.
All right. Thanks, Christy. You have a good day.
Thank you.
Be sure to check out the description for additional resources on this topic. If you enjoyed this content, give us a like. If you'd like to see more of this content, be sure you subscribe. Thanks for watching. We'll see you next time on the Tech Insider.